Well, just see it. If you can see it, then tell me. If you can't see it, then also tell me. First of all, you must see this. Can it be seen? If not, I can go show you. Okay. This is the alternator.
Let us discuss about alternator or synchronous generator. AC power can be generated as a single phase or as a balanced polyphase system. However, it was found that armature, the three coils are so placed in space that their axes are mutually 120 degrees apart.
I will
As shown
explain
here.
that later. Just
Through
see.
the terminals of the armature, three-phase power is obtained. Rotor houses a field coil and, excited by DC, the field coil produces flux and electromagnetic poles on the rotor circuit. Because the present value of flux linkage with our phase coil will take place after 120 degrees with Y phase coil and further 120 degrees after with B phase coil. A salient pole alternator has projected poles. As shown, it has non-uniform air gap and is generally used where speed is low. On the other hand, a non-salient pole alternator has uniform air gap and
Then I must show you the basic things.
Electromagnetic induction. In this lesson, we shall learn about electromagnetic induction. The phenomenon of electromagnetic induction can be demonstrated by an experiment. Wind an insulated copper wire on a paper or wooden cylinder so as to form a coil in the form of a solenoid. Connect the two ends of the coil to a galvanometer and place a magnet close to
See
it.
this to try to understand this.
The reading of the galvanometer is 0 when the magnet is stationary.
See this.
The pointer of the galvanometer deflects towards the right
Movement.
when the north pole of the magnet is moved towards the solenoid. The galvanometer shows 0 reading when the motion of the magnet stops. This proves that as long as the magnet keeps moving, current flows in the solenoid. If the magnet is moved
It's
away
actually
from the solenoid,
the Lenke's
current
law.
flows in
Actually
opposite
the Lenke's
direction
law.
in the solenoid. Thus, the galvanometer deflects towards the left. The deflection increases if the magnet is moved away with greater velocity. If the polarity of the magnet, or by increasing the motion of the magnet, increasing the area or the number of turns also creates a strong current in the coil. According to Faraday, when there is no relative motion between the magnet and the coil, the magnetic flux within the coil remains constant.
Now you can
So the
see that the
galvanometer
Faraday's
shows
law.
no
The
deflection.
Faraday's law.
But when the magnet is moved towards the coil or
And
vice
you
versa,
will
the
see
magnetic
then
flux
that there is a
changes
right hand rule.
and an EMF is induced in the coil. If the circuit is complete, the EMF causes current to flow through it. Based on his experiment, Faraday formulated two laws of electromagnetic induction. Whenever there is a change in the magnetic flux linked with a coil, an electromotive force is induced. The magnitude of the induced EMF is directly proportional to the rate of change of the magnetic flux linked with the coil.
That is the DFDT. That is the DFDT.
The direction of the induced EMF depends on whether there is an increase or decrease in the magnetic flux.